What's up, young scientists? Rajesh here, and today we're going on a high-speed adventure through the world of physics. Ever wondered how your phone knows north, or why dust floats in a sunbeam? It's all science. Today, we'll unpack 4 mind-blowing principles: how electricity meets magnetism, how light can push things, the rules of water flow underground, and why dust falls differently than a bowling ball. Get ready for some fun animations and rapid-fire explanations. Let's jump right into our first principle. First up, let's dive into the fascinating world of the Hall effect, a phenomenon that reveals the hidden behavior of electrons in a magnetic field. Imagine electrons flowing smoothly through a metal ribbon, just like cars cruising down a multi-lane highway with no obstacles in their way. Each electron follows its own lane, moving straight ahead. But now, introduce a magnetic field, like a giant invisible hand reaching down. Suddenly, all those electrons get nudged sideways, piling up on one edge of the ribbon. This shift creates a voltage across the ribbon, perpendicular to the current. This sideways voltage is called the Hall voltage. It's not just a random effect, it's directly linked to the strength of the magnetic field and the speed of the electrons. The Hall effect is everywhere. It's how your phone's compass knows which way is north, how cars measure the speed of spinning wheels, and even how spacecraft detect and map magnetic fields in space. By turning invisible magnetic forces into measurable, useful signals, the Hall effect bridges the gap between the physical world and digital technology. So, next time your map app points you north or your car's dashboard tracks your speed, remember, it's physics in action, quietly working behind the scenes. Edwin Hall discovered this effect back in 1879, and over a century later, his simple yet brilliant idea continues to power the technology we rely on every day. That's the incredible impact of the Hall effect. Now let's dive into the fascinating world of the Compton Effect, a discovery that shook the foundations of physics and changed how we see light forever. Picture a photon. Imagine it as a tiny, energetic billiard ball, speeding through space and smashing into an unsuspecting electron, which is just sitting there, minding its own business. When the photon collides, it bounces off the electron, but not without a cost. It loses some of its energy, which causes its color to shift from blue to red. Meanwhile, the electron is sent flying away, energized by the impact. This dramatic interaction was undeniable proof that light isn't just a wave, as scientists once believed. It can also behave like a particle, carrying energy in tiny discrete packets called photons. The Compton effect became a cornerstone of quantum mechanics, helping us understand how powerful X-rays and gamma rays interact with matter at the smallest scales, right down to the atoms themselves. This discovery isn't just important for science textbooks. It's crucial for real-world applications, like using gamma rays to target and destroy cancer cells, and for unraveling the mysteries of cosmic events, such as the intense light around black holes. By carefully measuring how X-rays scatter off electrons, scientists can unlock secrets about the universe's most extreme and energetic environments, from the hearts of stars to the edges of black holes. Light's particle punch was a breakthrough that forever changed the way we understand the universe and the rules that govern it. Thanks to Arthur Compton's groundbreaking work in 1923, we now see the universe through a new lens, one that reveals the hidden quantum world all around us. That's the true power of quantum thinking. It opens our minds to the wonders and mysteries of the universe, inspiring us to keep exploring. Let's get down to earth with Darcy's Law. This principle explains how fluids move through porous materials, like water through sand or oil through rock. The flow rate depends on pressure difference, permeability, how connected the pores are, and viscosity, how sticky the fluid is. More pressure and permeability mean faster flow. More viscosity means slower flow. Darcy's Law is vital for oil extraction, groundwater management, and even farming. Engineers use it to predict how much water or oil can be pumped from underground. It helps us protect drinking water and track pollution. It's the hidden rule behind one of Earth's most precious resources. Simple, but world-changing. Finally, let's explore why tiny things float and drift so gracefully, thanks to a fascinating principle called Stokes Law, which governs the science of slow falling. Imagine dropping a grain of sand into a jar of honey. Instead of plummeting straight to the bottom, it sinks ever so slowly. That's because the thick, sticky honey creates a powerful drag force that resists the sand's fall, making it descend at a gentle pace. Stokes' law tells us that this drag force depends on 3 things: the viscosity of the fluid, the size of the object, and how fast it's moving. The thicker the fluid, the more it resists motion. The bigger the object, the more drag it experiences. And the faster it tries to move, the greater the resistance. So, if you compare a sphere falling in water to one in honey, the one in honey sinks much slower. Larger spheres, or those moving quickly, also feel more drag, making their descent even slower in thick fluids. As the grain falls, the drag force increases until it perfectly balances the pull of gravity. At this point, the grain stops accelerating and falls at a constant slow speed. This is called terminal velocity, and it's why the motion looks so smooth and steady. This same principle explains why dust and pollen can float in the air for so long, and why clouds made of countless tiny droplets remain suspended high above us instead of falling straight down. Stokes' Law reveals the secret behind the gentle, mesmerizing dance of particles in a sunbeam, swirling and drifting as if weightless. It's the physics of resistance at its most delicate, where even the tiniest forces can have surprisingly big effects on motion. So next time you see dust floating in a sunbeam, remember, it's not magic, but the beautiful science of tiny forces at work, shaping the world in ways we often overlook. And there you have it, 4 powerful science principles in just a few minutes. From invisible forces in your phone to the way dust floats, these ideas shape our world and technology. I hope you're inspired to keep asking questions and exploring how things work. If you enjoyed this, hit like, share, and subscribe for more science adventures. Stay curious and see you next time.